angels come down, help with this parade. To hear your voice ring out, come on and shout it, let your soul be heard. This is the time, this is the day that we've been waiting for. All the world stop to watch you shine.
Welcome to Revive with Mrs. C. We're having a look at ionic bonding, or the drawing of ionic bonding. Ionic bonds involve a metal and a non-metal, and it refers to a transfer of electrons. So the first thing you need to do when you're drawing a bond, or an ionic bond, is draw the original atoms to start with. So this question here is asking about sodium iodide. So I'm going to first of all draw sodium, and then I'm going to draw iodide. So sodium I need to find on my periodic table, and if we have a look at our periodic table, we know that sodium is a metal, so it's going to be on the left hand side. Here it is here. It's in group 1, so it's going to have 1 electron in its outer shell, and it's in period 1, 2, 3. Third row down, so it's going to have 3 shells. So if I go drawing 1, 2, 3. If you don't like drawing diagrams in terms of circles, you don't think they're neat, don't worry about it. As long as we can see that they're circles, it doesn't have to be neat. The first shell, there's always 2 electrons. In the next shell that's full, then there is 8 electrons. So I'm going to go ahead and draw those. And we found out, because sodium is in the first group, it only has 1 on the outer shell. And the reason why I've drawn that on that angle there is because it's very easy to see it there. Alright, iodine I'm going to draw now, and iodine is a little bit bigger. If we have a look here, it's in group 7, so it's got 7 electrons in its outer shell, and let's check how many shells it's going to have. 1, 2, 3, 4, 5. So it's a bit of a mighty atom, this one. So let's see if we can draw that. 1, 2, 3, 4, 5. Nice big one. Okay, it's got 7 in its outer shell, so 1, 2, 3, 4, 5, 6, 7. That's done. Now I'm going to draw the other shells. 1, 4, 2 in the first shell, 8 in the second shell, and so on. In this next shell over, there's actually 18, and the reason why I know that is because if I start here and I count along, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. I'll end up getting to 18 up here. So go ahead and have a go at doing that yourself, but I'm going to put in my first 8, 9, 10, 11, 12, 13, 14, 15, 16, and I'm going to put 2 more somewhere where they might fit. There we go. Okay, I then see that this is really, really messy. So actually, do I want to spend the time to draw this in an exam? No, I definitely do not. So that's what it should look like, but let me show you a different way of drawing it before we actually answer the question. And you might see that this is much easier. All right, I'll redraw sodium here, and I'm only going to draw him with 1 shell. And that's the same with iodine. And what I'm going to draw is purely the outer shells. So I'm just right there, outer shells drawn. And because of this question, you'll understand why I'm suggesting this. So in sodium, we found out that there was 1 electron, and in iodine, we found out that there was 7 electrons in the outer shell. Now, can you see how quick that was to draw that in comparison to that? So when you're in an exam and it's asking you to draw an ionic bond, please don't draw all of the shells. I did that on purpose so you could see exactly what a mess it can become and how much time it takes. So please only draw the outer shells, but we're not finished. In order to show an ionic bond, because what I've got here is both just atoms at the moment, I need to put square brackets around both of them. And as I said at the beginning of this clip, we need to say that ionic bonding involves a transfer of electrons. So I want to demonstrate that. So I'm going to push that over to there with an arrow and then place that cross there. So I can now see that that electron has been lost or transferred to iodine. So if I was to turn sodium back to being an atom, what would I have to do if it's lost this 1 electron? I'd have to add 1 electron back. So I'm going to give it a charge of +1. And the same with iodine. In order to return iron to its original atom, I have to lose this one electron. So I'm going to put -1 there. And what this does is it forms an instruction for what you need to do. Now it's your turn. Have a go at doing sodium chloride. As I mentioned before, make sure that you use just the outer shell. So I'm going to write down sodium and chlorine and 1 shell around each. Sodium we know is in group 1 from the periodic table, so I'm going to put a cross there, and chlorine is in group 7, so I'm going to go ahead and draw 7 electrons in the outer shell, square brackets around both, and showing that electron crossing across. So in order to return chlorine ion back to an original atom, I need to lose 1 electron, and in order to turn sodium back to an atom, I need to gain 1 electron.